Now we know that a polygon is a many-sided figure. So all of these figures qualify as polygons. Our 4-sided, our 5-sided, our 7- and 8-sided figures are all categorized as polygons. And then there's specifically quadrilaterals, 4 sides, triangles, 3 sides, pentagons, 5 sides. But in the scheme of things, polygon means many-sided. We have something called a regular polygon and an irregular polygon. Regular polygons have this distinction. All sides and all angles are equal. So in this case, our square has 4 sides that are the same length, and all of the angles measure exactly the same, regular. In an equilateral triangle, all the sides of this equilateral triangle measure exactly the same length, and the vertices measure the same. So these are very pleasing shapes too, because they have all of the sides are the same and all the angles are the same. So we've got a pattern to those. Irregular shapes still can qualify as quadrilateral, quadrilateral, quadrilateral. But these are irregular shapes because they have either different size lengths to their sides, or they have different size angles. Let's look at this rhombus. Obviously, the 4 sides are the same. They measure the same length. But we have 2 obtuse and 2 acute angles in this figure. It does not qualify completely as a regular polygon. The sides are equal, but the angles aren't. So we would have to put it over here in the irregular. So you should be on the lookout for that, because that certainly does have all 4 sides the same, and your eye goes right to it. Now that we understand the difference between a regular and an irregular polygon, we can actually use this formula, n minus 2 equals 180, in order to figure out the total amount of degrees in all of the angles of any given polygon. In this case, we have our equilateral triangle, n minus 2 times 180 degrees. The number of sides in this triangle are 3. So that's our n number. 3 take away 2 times 180 degrees. 3 take away 2 is 1, times 180 degrees is 180. So this triangle has 180 degrees total angles in and among its shape. We can now take our 180 degrees and find out how this 180 degrees is distributed evenly among the 3 angles. So 180 divided by 3 gives us 60. So we have 60 degrees in each of these angles. The square. The number of sides, 4. 4 take away 2 times 180. 4 take away 2 is 2 times 180 gives us 360. There are 360 degrees in this quadrilateral. We know that the square has 90-degree angles, 4 right angles. Let's see if mathematically that works out. 360 divided by 4 gives us 1, 2, 3, 4, 5 sides on this one. 5 take away 2 is 3. 3 times 180. That's 24. I'm carrying 2, 3, 4, 5. There's 540 degrees in the pentagon. The total angles have 540 degrees. If we were to split those up among the 5 angles, we would have 5 goes into 5 once. 5 doesn't go into 4, so we're going to put a 0, but this moves over to 40. 5 goes into 40 8 times. Each of these angles has 108 degrees in each one. The octagon. 1, 2, 3, 4, 5, 6, 7, 8 sides in our octagon. N is 8 this time. Subtract 2 times 180 degrees. 6 times 180 degrees. That's 48. Carrying 4 this time. 6 and 4 is 10. There are 1,080 degrees among the angles in this regular polygon. 8 goes into 10 once, with 2 left over. 8 goes into 28 3 times. That's 24. 2 factors 6 to 7, 28. We're going to have a remainder of 4. 8 goes into 40 5 times. Each of the angles has 135 degrees. It's split up equally among all of the angles, and so forth and so forth and so forth.